geometric sequences in series. So let's start off with the definition. Let's see. A geometric sequence, I'm going to abbreviate sequence here, is a sequence in which each term after the first is the preceding term multiplied by a common ratio r. Alright, so similar to arithmetic sequences, except here we're multiplying each term by a common ratio r. So earlier we had a common difference d, here we have a common ratio r. When the common difference from the arithmetic, we were adding the same number from term to term, or the difference was the same from term to term. Here with common ratio, the thing we're multiplying from term to term is the same, and that's called r. Alright, and I'm going to go ahead and give you the formula for a geometric sequence. So it's a sub n is equal to a1, and then we're multiplying that times r, our ratio, raised to the n minus 1 power. Alright, let's look at an example here. Example 1. Find the common ratio. And here's part A. 3, 6, 12, 24, 48, and so on. Alright, so you can see here, well, first let's see what the common difference would be. 3 to get from 3 to 6 would be, you have to add 3, then you have to add 6 to get here, and then add 12. So we can see that the common difference doesn't work here. Let's just try some things. How to multiply to get from 3 to 6, we have to multiply by 2, so that works. To get from 6 to 12, we have to multiply by 2. 6 times 2 is 12. And then get from 12 to 24, we have to multiply by 2. So it looks like r is going to be 2. Alright, but these can be a little tricky doing it by hand or in your head like I did, especially on some later problems. So this will work similar to how I showed you finding the common difference. This is A1, this is A2, A3, and so on. So they're labeled the same. So to find R, what you need to do is take A2, the second term, and divide it by A1. And what you get is 6 divided by 3, which is 2. Alright, and so you typically want to check several of these ratios to make sure that it really is a common ratio and that they're the same throughout. So let's try one more. And so what I mean by one more, now let's do A3 divided by A2. Alright, so you just take the term you're on and divide it by the preceding term to get your common ratio. So A3 is 12, A2 is 6, which is 2. So my R will equal 2 here. Alright, what about this one? Give this one a try by yourself. Pause the video, and then if you need help, unpause it. So R will equal A2 over A1. So A1, A2, A3, and so on. So what I'm doing is I'm taking A2 divided by the preceding term A1. So that's equal to 6 divided by 18, and that reduces to 1/3. So to get from 18 to 6, I needed to multiply 18 times 1/3, which gave me 6. Let's try one more. Let's take A3 and divide it by the preceding term, A2. A3 divided by A2. So that gives me 2/6. Simplifying gives me 1/3. So R is 1/3. All right. Let's move on to another example. In this one, this is just to get you used to how the geometric sequence works and how it multiplies itself out. So let's say find the first 4 terms if A1 is 5 and R is equal to -2. So I didn't outright give you the sequence that we wanted to use. Here you're going to have to create the sequence. And there are some hints in here in this example. I encourage you to pause the video and try to work it yourself and use me as a guide if you need to. So what hint I gave you and to know what formula we need to use is I gave you R. R means the common ratio, and that should immediately ping in your mind that you're going to be using the geometric sequence. So first thing you always do is write the formula. AN is equal to A1 times R raised to the n minus 1 power. Should have wrote that a little bigger. All right, and then let's plug in the things that we know. We know A1 and we know R. They're just given to us. So AN is equal to A1, which is 5, times R, which is -2, and that's raised to the n minus 1 power. So there's our formula. And all we want to do now is find the first 4 terms of this. So go ahead and pause the video again and do that part. A1 means we plug 1 into this sequence for n. 5 times -2 raised to the 1 minus 1 power, which is equal to 5 times -2 to the 0. Anything to the 0 power is 1, so 5 times 1 is 5. A2 means we're plugging 2 into this sequence everywhere there's an n. So 5 times -2 raised to the 2 minus 1 power. That's equal to 5 times -2 to the first, which is 5 times -2, which is -10. A3 means we're plugging 3 into the A sequence everywhere there's an n. So 5 times -2 raised to the 3 minus 1 power. So 5 raised to the -5 times -2 raised to the second power. That's equal to 5 times a positive 4, which is equal to 20. Alright, and one more, A4. That's 5 times -2 to the 4 minus 1, which is 5 times -2 cubed, which is equal to 5. And then -2 times -2 is a positive 4, times -2 again is a -8. So here I get -40. All right. One more example. Example 3. Let's say write the formula given the sequence 2, 3, 9/2 27/4. Dot, dot, dot. Alright, pause this one and give this one a try. Alright, so let's label. First thing I know, A1 is 2. And then I need to find R. I know I'm going to have to find that eventually. So let's go ahead and do it now. So to find these, it's A2 over A1. So 3 divided by 2. And that would be your R. And you can go ahead and try A3 divided by A2. You'll still get the same thing, 3/2. Alright, so let's write our formula. So A1 we said was 2. R was 3/2 raised to the n minus 1 power. And that's all I got for this one.